Hello everybody and welcome back to Elementary Statistics online at Frederick Community College. This is the second part of the mini lecture on section 9.3, which is dealing with hypothesis testing with paired data. And let me just remind you that the first example that was solved, that was about grades for students in marketing and finance courses. And we determined that there was not a significant difference between these scores. Okay, so the next example will be just a little bit more challenging and has a lot more room for potential errors. So I want to go through this one slowly. Let's take a look at what we have here. We have American Greetings Company, who would like to test the hypothesis that the average amount of money spent per person on Mother's Day increased by more than $7 this year when compared to last year. Okay, so just like before, let me highlight a couple of different things. This is about mean spending, and we want to see if that spending went up by more than $7. Okay, the following data represents the amount of money that the same 8 individuals spent on Mother's Day during the past 2 holidays. Again, we have a sample of 8 subjects. We have normality satisfied, that's assumed. So that means we can actually conduct a hypothesis testing. And if you inspect these numbers right here, you will see that in most cases, people did spend more money this year than last one, right? So for example, person number 3 almost double their budget. Okay, this person right here spent 23 more dollars. This person spent 20 more dollars. So you can see there's actually some ground for hypothesis testing in this case. Okay, so the null hypothesis in this case will say that there is no difference, but we've got to be careful. The difference is less than $7. Okay, less than or equal to. How do I know? Okay, over here, my hypothesis is that the difference is greater than 7, right? So the money that was spent this year, the amount increased by more than 7. Okay, so this should be the opposite. So the difference over here is more than $7. Okay, and this is a perfect example where the value in the null and alternative hypothesis is not 0. Very important to just catch that number right here. Okay, it's not going to be 0. In most of the times, most of the problems, it is 0. So if you look at problem 1, yes, we said mu d is equal to 0, not 0 here. This is not the case. So as far as notation goes, you would say mu of d, not 9, less than or equal to 7, okay? And then here we want to see if people spent more money, and by how much more? More than $7 per person, okay? So next thing to do is to type in all of our numbers in the calculator. And I already did that to save some time. So in the first column, I have spending for previous year. And then in the second column, I have spending for this year. Okay. And now I need to find the difference. And this is the second part where a mistake can happen. The order of operation in this case matters. Okay, so the order of subtraction, I'm going to say L3 is equal to L2 minus L1. Okay, and why am I doing this? Because supposedly the numbers are higher this year, right? So it makes sense that I need to subtract last year numbers from this year. Now, some of them will be negative. So you see the first person spent less money this year than before. Okay, but if you inspect your differences, you can actually see, oh yeah, most people spent more than $7. Okay, this person spent 12 more, this person spent 33 more dollars, and so forth. Okay, so this is very important to pay attention on what order you're using for your subtraction. Okay, so I'm actually going to make a note over here, and I'm going to make it in a different font. Let's make it red to emphasize that L3 is the difference in the amount spent, okay, and L3 is actually going to be L2, or this year minus last year, okay? All right, so once we do this, we have our spending. That's done, or the average difference, right? We're gonna go back to stat, t-test, and over here we need to put in 7. Okay, we want to see if the number is if the numbers went up by more than $7, right? So list, that's L3, frequency still keep 1. I'm changing this part right here to greater than or equal to. Okay, well, this is greater, right? So then we're gonna go ahead and compute our p-value. What is the p-value? We're gonna get 0.078. So I'm gonna say I used t-test on L3, p-value 0.078, which is less than alpha level, right? Alpha level was 0.10. Okay, so what is our conclusion? We reject the null hypothesis. There is sufficient evidence to claim what? To claim that, and you can just copy and paste, to claim that the average amount of money spent per person on Mother's Day did go up by more than 7. Okay? There is sufficient evidence to claim that the average, I have too many words here, amount of money spent per person on Mother's Day did increase by more than $7 this year when compared to last year. Okay? So, a couple of things that I want to mention. Mistake number 1 that can happen. Let's just go ahead and list them here. Why not? Okay, mistake number 1 can happen. So these are your mistakes. Using two sample t-test. That mistake number 1. Okay, we're not going to use two sample t-test here. We have paired data, right? So paired data meaning these numbers come in pairs. This is dependent sample, right? Dependent data, which means we will be using t-test. Okay. Then the other mistake that can happen, using 0 instead of 7. Okay, that will give you different answer. You will probably still, most likely still reject the null hypothesis that p-value will be different. Then you're basically asking that there is no difference. Okay, but the question is asking, did the amount of money went up? Did it actually did it go up by more than $7? Right, that's slightly different. Okay, and then the last thing that can happen is order of L1 and L2, or whichever columns that you're using, okay, matters when finding the difference. Okay, so there is no rule here. You just have to read the problem carefully, right, and say, okay, what am I trying to do here? In this case, we wanted to see if these numbers right here were higher than before, than a year ago. So it's the L2 if you put this in L2 minus L1. Okay, so these are your mistakes to avoid. Okay, let me make sure that we know these are mistakes to avoid. And you can actually see real quick. Let's go ahead and run this test with a different order. You'll see what's going to happen. Let's go back to our L3. Okay, let me go back up here and do L1 minus L2 instead. Okay, so now what I'm getting is all of these negatives, right? Which, if you look at your alternative hypothesis, this doesn't even make sense, because the alternative hypothesis on average, the difference is greater than 7, Well, not almost all of your numbers are negative. So you don't even have any grounds to run this hypothesis testing. Which means what? If you run this test with the way you set it up, let's go ahead and run it. Everything else is the same. We just want to see what's going to happen if I put it in a different order. Let's compute it. Look at your p-value. P-value this big is the red flag that you're looking for. Okay, p-value almost close to 1. That should tell you right away something went wrong. I did something wrong. Maybe the order of the order that I used to find the difference. That's most likely what that is. Okay, so then you go back to your differences and say, do these numbers actually make sense for this hypothesis? They don't. Look at all these negatives. Okay, they don't match. They actually don't match what your alternative hypothesis is. So you say, oh, okay, I know what I did. I just did that in a different order. Okay, boom. You get your numbers here. Let's go back and run the test. Everything else is the same. Run the test. Now you know you've done it right. Okay, so again, in general, p-value large enough, too big. So if you have a p-value close to 1, is a good indicator that something went wrong. Okay, and my hint is most likely HA was not set up correctly. Okay. All right, so here's your unusual example of hypothesis testing with paired data. Okay, different places where a mistake can happen, but now that you guys know about these potential problems, try to avoid them. Okay, keep in mind all of these things that I just discussed. Okay, well, I hope this was helpful. Thank you for watching.